application is the fabrication of floating titanium photocalytic diatomite modified by iron granule catalyst with enhanced photocatalytic efficiency. Work plan, introduction, objectives, materials and experimental methods, characterization of aluminosilicate materials, photodegradation of green endothelial textile dye by diatomite modified by ferrihydride with UV process, and finally conclusion and prospects. The main phases of ferric oxide in nature in ascending order of crystallinity are ferrihydride, magimite, lipidochrosite, hematite, and goethite. Ferrihydride is a less crystalline brown iron oxide with a large surface area. An alternative to granular ferric hydroxide absorbance among these materials is diatomite with chemical formula SiO2 NH2O, which is a soft light rock composite of amorphous silica microfossils of aquatic algae. Use of dyes. Synthetic dyes are increasingly used in textile and industrial dyeing. Some dyes are carcinogenic and mutagenic. The application, photocatalytic. In our case, the catalyst is diatomite modified by iron. Then, the photodegradation of textile dye, but green zero-3 endothelium by heterogeneous photocatalysis used light source UV lamp from transiminator, plus co-adsorbent activated diatomite modified by iron, depending the pH of the medium and irradiation time. The gap energy of titanium dioxide modified diatomite equal to 3.2 electron volt, and our catalyst diatomite modified by iron with the gap energy in the range between 1.6 and 2.7 electron volt. Materials and experimental methods. Diatomites are very light, very porous siliceous rocks formed mainly to the accumulation of oval crystal of diatoms. Diatoms are unicellular microorganisms generally between 10 and 15 microns size, characterized that they are the only unicellular organism to have a siliceous outer structure completely enveloped with the supernatant and rigid cellular apparent crystal. There are two types of diatoms, centric diatoms and pinnate diatoms. Origin of raw diatomite of SiC. The diatomite used in this study comes from the region of SiC, 50 kilometers from the city of Oran, in the valley of Mascara, in the west of Algeria. It is in the form of a white powder after grinding with mortar and agate pestle, and saving the particle size of the fraction is between 0.4 and 0.6 millimeter. This figure is a graphic situation. The shades of these materials was detected by the fact that it's very abundant. It has an absorption affinity towards and heavy metals and organic molecules. Application areas: absorbance, pesticide, purification of drinking water, construction and thermal insulation, chromatographic and catalytic supports, abrasive products, biotech products, atomic industry, and antibiotic manufacturing, pharmaceutical silo. Preparation of diatomite modified by ferrihydride. We take 45 grams of raw diatomite plus 0.5 grams of titanium dioxide. Then we add the solution of sodium hydroxide with concentration 6 molar. Then we make a sealing at 90 Celsius degrees for 2 hours to partially dissolve silicon. Then we add the ferrous chloride tetrahydride with concentration 1 molar. Then sealing and oxidation around temperature for 24 hours. Then solidification for 20 minutes to remove the supernatant. Then wash with distilled water. After oxidation by air for 24 hours to continue the removal of excess of soda and oxidation of iron to hydroxide. Then solidification after drying in oven at temperature 105 degrees for 24 hours. We obtain diatomite modified by ferrihydride. This figure. Preparation of diatomite modified by ferrihydride with calcination at 600 degrees. We take diatomite modified by ferrihydride, then calcination at 600 degrees in tubular oven with the speed rate of 1 Celsius degrees per minute during 24 hours to obtain diatomic modifier bifurcated with calcination and characterization. This figure. Characterization of aluminum silicate materials. Quantitative mineralogical analysis by X-ray fluorescence. For raw diatomite of SiG, so dominates 4 oxides as silica, iron 3 oxide, alumina, and calcium oxide. And for diatomic modifier bifurcated with calcination, so dominates 4 oxides as silica, iron 3 oxide, sodium dioxide, and alumina. Analysis by X-ray diffraction. For diatomite of SiG, there are many phases as quartz, albite, iolite, neutronite, muscovite, plagioclase, opile ice, mactite, kaolinite, montmorillonite, feldspar, calcite, lepidocrosite, dolomite, diopside, rutile, and aragonite. And for diatomic modified bifurcated with calcination at 606 degrees, there are the new phases as ferrihydride 6-line, magimite, hematite, galtite, and anatite from titanium dioxide. Fourier transform infrared spectroscopy. For diatomite of SiG, there are many absorption bands. The absorption bands are from calcite, the absorption band of OH from water physosorbate, the absorption band from silanol groups, the absorption band of siloxane groups, and the absorption band of cerite group. For diatomic modified bifurcated with calcination, there are the new absorption bands. The absorption bands of OH from water, interaction between water physosorbate and the diatomic modified bifurcated. The new absorption band from silan, the absorption band from the ferric oxide, for example, magimite, hematite, and magnetite, and the absorption band from oxidroxide, ferric oxidroxide, for example, galtite and lepidocrosite. Morphological characterization by scanning electron microscopy. For diatomite of SiG, there are 2 types of particles, centric particles with the diameter in the range between 0.09 and 0.5 micrometer, and the pinnate particles with the length in the range between 2.5 and 3.5 micrometer. For diatomic modified bifurcated with calcination, there are 2 types of particles. Pinnate particles with the length in the range between 3.3 and 15 micrometer, and the width in the range between 1.6 and 7.6 micrometer, and the centric particles with the diameter in the range between 1.6 and 8 micrometer. Thermal analysis, thermogranulatometry analysis, and digital scanning calorimetry. For diatomite of SiG, there are two phases in the range of temperature between 50 and 700 degrees. For the first phase in the range of temperature between 50 and 200 degrees, with loss white 0.75% departed of physosorbate water, and the second phase in the range of temperature between 200 degrees and 700 degrees with white loss 2.5% departure of silanol groups, deoxidation. And for diatomite modified bifurcated with calcination, in the range of temperature between 50 and 1200 degrees. For the first phase, in the range of temperature between 50 and 200 degrees, with white loss 1.67% departure of physosorbate water, and the second phase in the range of temperature between 200 degrees and 1020 degrees, with white loss 37.91%, decomposition of organic phase and optionally of declination of silanol groups, and we obtain hematite products. And the two endothermic peaks in the two temperature. For the first temperature, 795.28 Celsius with enthalpy 156.2 joule per gram, and the second endothermic peaks in the temperature 1027.76 degrees with enthalpy 465.4 joule per gram. Surface charge use SERS methods than potentiometric titration. The surface charge in function of pH, we obtain the pH of 0.0 charge equals 6 for thermal modified parfairedite with calcination. Irreversible diffuse electron spectroscopy use TOC methods for thermal modified parfairedite with calcination. The maximum wavelength is 238 nanometers. For the TOC methods, we obtain the gap energy of this catalyst that was modified parfairedite with calcination equal 1.60 electron volts. And the application Photocalytic for photodegradation of very zero industrial textile on presence of that modified parfairedite with calcination use UV irradiations. The important study what we zero industrial textile from textile industry in Sinia in the wilaya of Oran. The characteristics of this pollutant, maximum wavelength 238 nanometers, pH 6.9, and solubility in alkaline solution. Test for the degradation, we take 200 milliliters of 1.0 with concentration 20 milligram per liter with 3 medium pH 4, 7, and 10. Plus we add 0.5 gram of Diatomite modified parfairedite with calcination. We use the UV lamp of the transiminator with wavelength 365 nanometers. The kinetic of photodegradation with the first the order, and the best result at the discoloration removed in pH equal 4 for decoloration removed 97%. There's photodegradation after photodecolorization with this balance of solution control. Conclusion: the co-absorbent of Diatomite modified parfairedite with calcination gives a better rate of discoloration, approximately 97%. Thus, the use of this catalyst, Diatomite modified parfairedite with calcination, for the degradation of textile dye, the particularly indothermic in the UV lamp is economically efficient method compared of titanium dioxide commercial. For the later is more expensive. Prospects for the final results obtained, some prospects have been proposed, which are initiate different methods of analysis of prepared diatomite, use other analysis, magnetization, atomic force microscopy, X-ray photoelectron spectroscopy, X-ray near edge absorption spectroscope examines, measure of surface area, brunette emitted and transmission electron microscopy, make a synthesis of several mixtures, diatomite plus cement or diatomite plus zeolite or diatomite modified by manganese, use manganese to chlorine to increase the surface area and the porosity. Measures of organic initiate different methods of analysis of prepared diatomite and its precipitates after the photocatalytic reaction. Use Fourier transform infrared and nuclear magnetic resonance. And measures on organic materials of the dye and their textile relies to determine the pollution parameters, chemical organic demand, biochemical organic demand, and total organic carbon before and after the photocatalytic reaction, photoionization, and to identify and know by products gas chromatography, mass spectrometry, and nuclear magnetic resonance. And thank you for your attention.